You look in the mirror every morning. You see your eyes. Blue, green, hazel, brown. You have never once questioned why they are that color. But the real answer is far stranger than you think. Every blue eye on Earth today traces back to one single person. Not a population. Not a region. One person. Somewhere near the Black Sea, between 6 and 10,000 years ago, a tiny genetic accident happened inside one human body. That accident is still living inside your face right now. Your eye color comes from a pigment called melanin. Brown eyes have a lot of it. Blue eyes have almost none. Green and hazel sit somewhere in between, scattering light in ways that make the iris look like it's shifting color depending on what you're wearing. But melanin didn't just decide to disappear for no reason. Something changed. Something broke. In 2008, a geneticist named Hans Eyberg at the University of Copenhagen traced the origin of blue eyes to a single mutation in a gene called OCA2. That gene normally controls how much melanin your body produces. The mutation didn't destroy the gene. It just switched off part of its instructions like a dimmer switch getting stuck near zero. Suddenly, one person's iris stopped producing brown pigment. And because that mutation worked, it survived. It spread. Here's the part that made Eyberg's team pay attention. The mutation doesn't actually sit inside the OCA2 gene itself. It sits in a neighboring gene called HER2, right next to it on the same chromosome. That neighboring gene acts almost like a switch panel, reaching over and turning OCA2's activity down. Think of it less like a broken machine and more like someone reaching over and dimming the lights in the next room. The machine still works. It's just being told to work less. And because every blue-eyed person on the planet carries a version of that switch that traces back to the exact same genetic signature, Eyberg's team could say something remarkable with real confidence. Every blue eye alive today shares one common ancestor. Not culturally, not symbolically, literally at the level of DNA. You could be Norwegian, Ukrainian, Irish, Kazakh, or Argentinian with distant European ancestry, and if your eyes are blue, that exact mutation traces back to the same person in the same region at roughly the same slice of prehistory. Why would a random genetic accident spread across an entire continent? For decades, biologists assumed eye color was meaningless, a cosmetic detail, the kind of thing evolution wouldn't bother selecting for because it doesn't help you run faster, digest food better, or fight off disease. But if that were true, blue eyes should have stayed rare. A fluke, buried in one bloodline, diluted into nothing within a few generations. That's not what happened. Instead, the mutation exploded across northern and eastern Europe until, in some regions today, nearly the entire population carries it. Something was pushing it forward. This is where the story stops being about genetics and starts being about ice. Around the time this mutation appeared, much of northern Europe was locked under a brutal, low-sun climate. Short winters, long gray skies. Populations that had migrated out of Africa thousands of years earlier were now living somewhere their bodies were never designed for. Darker skin, built to block intense equatorial sunlight, was suddenly a liability. Without enough sun exposure, the body struggles to produce vitamin D. And a vitamin D deficiency over generations causes weakened bones, poor immune function, and lower fertility. So lighter skin began to spread. It let more sunlight in. It helped bodies survive. Consider the timeline for a moment. Modern humans left Africa somewhere around 60 to 70,000 years ago. For most of that migration, skin remained dark, because dark skin was still the safest option under strong sun. It wasn't until certain populations pushed far enough north, into places with weak, low-angle sunlight for much of the year, that the old advantage flipped into a disadvantage. Suddenly, the very trait that had protected people near the equator was starving their bodies of a nutrient they desperately needed. Evolution doesn't plan ahead. It only reacts. And it reacted. And here's the part almost nobody expects. Eye pigmentation and skin pigmentation are controlled by overlapping genetic pathways. As the pressure to lighten skin increased across these populations, the same biological machinery that reduced melanin in skin also reduced it in the iris. Blue eyes may have been a side effect. A hitchhiker riding on the back of a much bigger survival trait. But that explanation on its own doesn't fully account for how fast and how far the trait spread. Vitamin D synthesis happens through skin. not through your eyes. So why would a random, non-functional side effect in the iris spread at the same explosive rate as the trait actually driving survival? This is where a second theory enters, and it has nothing to do with sunlight at all. Evolutionary anthropologist Peter Frost proposed something that initially sounds almost too strange to take seriously, that blue eyes spread not because they helped anyone survive the cold, but because they helped people get chosen. Frost's hypothesis centers on sexual selection, the same evolutionary force that gave peacocks their tails and deer their antlers. Traits that don't improve survival can still spread rapidly if they improve someone's chances of being noticed, remembered, and picked as a mate. Picture the environment those ancient populations lived in. Small tribal groups. Harsh, resource-scarce winters. High mortality. In a world like that, competition for mates inside a group could be intense, especially if population numbers were already thin from famine or disease. Frost argued that a rare, unusual, eye-catching trait, quite literally, could give someone a competitive edge in being selected as a partner. Not because blue eyes were better, because they were different. Noticeable, memorable in a sea of otherwise similar faces. Frost took the theory further. He pointed to something biologists call the rare male effect, originally observed in fruit flies and later studied across other species, where an uncommon physical trait can trigger disproportionate mating interest simply because it stands out from the crowd. Under conditions of extreme seasonal hardship, where a bad winter could wipe out a meaningful percentage of a small population, Frost proposed that pressure on mate choice would have been unusually intense. Fewer available partners, higher stakes, faster selection. In that kind of environment, even a small visual advantage could snowball across generations far quicker than it would in a large, stable population with abundant food and low mortality. It's a controversial idea, and not every researcher in the field agrees with how much weight sexual selection deserves compared to the vitamin D explanation. Most likely, the truth isn't one clean answer. It's both forces, tangled together. Climate pressure lightened the skin. The shared genetic pathway lightened the eyes along with it. And once that lighter eye color existed in the population, human attraction and mate choice may have grabbed onto it and pushed it further and faster than climate alone ever could have. Would people really choose a partner because of eye color alone? Maybe not consciously. But evolution rarely asks for conscious decisions. It only asks for outcomes. If even a slightly higher percentage of blue-eyed individuals successfully paired off and reproduced, generation after generation, that tiny advantage compounds. Multiply a small statistical edge across hundreds of generations, and a single mutation in one ancestor can end up inside the eyes of hundreds of millions of people. There's a strange twist to this story, and it involves trust. A study led by researcher Bruno Lang at the University of Oslo examined how people unconsciously respond to different eye colors, and one of the more surprising findings involved fear and instinct, not attraction. Some earlier research on this topic explored whether brown-eyed individuals were unconsciously perceived by others as appearing more dominant and blue-eyed individuals as appearing more submissive or approachable, based purely on the visual structure of the iris, not on personality or behavior. Your brain, in other words, may have spent thousands of years reading tiny facial signals that had nothing to do with who someone actually is. That means for thousands of years, before language, before writing, before any of the social systems you rely on today, humans were already making split-second judgments about each other based on eye color. Who to approach? Who to avoid? Who felt safe? None of it was rational. All of it was happening anyway. Now, here's where the story gets even stranger. Blue eyes are not actually blue. There is no blue pigment anywhere in your iris. Not one molecule of it. What you're seeing when you look at someone's blue eyes is the same optical trick that makes the sky blue. It's called Tyndall scattering. Light hits the collagen fibers in a low melanin iris and scatters, and shorter wavelengths, the blue end of the spectrum, bounce back toward your eyes more than the longer wavelengths do. The color isn't there. It's an illusion your brain constructs out of scattered light. Green eyes work through an even stranger combination. A small amount of melanin, usually a warm, amber-toned pigment called lipochrome, mixes with that same blue scattering effect, and the result reads to your brain as green, which is part of why green eyes are the rarest eye color on Earth, appearing in only around 2% of the global population. It requires a very specific, narrow overlap of two separate pigment conditions to land exactly there. So if you have blue or green eyes, you're not looking at pigment. You're looking at physics wearing a costume. Hazel eyes complicate the picture even further. They sit in a strange middle zone, carrying moderate melanin levels combined with that same light scattering effect, which is why hazel eyes seem to shift color depending on lighting, clothing, even mood, at least according to the people around you. There's no single hazel gene. It's a blend, a genetic compromise between the ancestral brown setting and the newer, scattered lighter tones, which is part of why hazel eyes are notoriously hard to categorize on official documents and driver's licenses. Your eyes, in other words, might not even fit neatly into the boxes humans invented to describe them. Brown eyes are the opposite story, and the older one. Nearly every early human on Earth had brown eyes. High melanin, dense pigment, an iris built to absorb light rather than scatter it. This wasn't cosmetic either. In the intense, high UV environments where early humans evolved, darker eyes may have offered some protection against sun damage and glare, the same logic behind why darker skin evolved in equatorial regions. Brown eyes are, in a very real sense, the ancestral default. Every other eye color you see walking down the street is a deviation from that original setting. Which raises an uncomfortable question. If blue and green eyes are essentially genetic byproducts, accidents that spread through a mix of climate pressure and mate selection, why do so many cultures throughout history treat them as something special? Ancient Greek and Roman writers frequently described lighter eyes among certain northern populations with a mix of fascination and suspicion, often associating unusual eye color with foreignness, otherness, sometimes even the supernatural. In parts of medieval Europe, unusually pale or light-colored eyes were occasionally linked to superstitions about witchcraft, precisely because they stood out from the expected norm. The very trait that may have spread because it was rare and eye-catching also made the people who carried it, at different points in history, targets of suspicion for that exact same reason. Rarity cuts both ways. It can make you desirable. It can also make you the outsider. Look at how differently the same trait was treated depending on where you stood. Among populations where blue eyes were common, they carried no particular weight at all, just another unremarkable face in a crowd of similar ones. But drop that same trait into a population where it was rare, and suddenly it meant something. Suddenly it stood out enough to be written about, feared, admired, or mythologized. The biology never changed. Only the surrounding population did, which tells you something uncomfortable about how humans assign meaning to physical traits in general. It was never really about the trait. It was about how common or uncommon it happened to be in the room you were standing in. That pattern didn't end in the ancient world. It shows up over and over throughout history, in the way certain features get treated as special the moment they're scarce and forgettable the moment they're everywhere. Today, roughly 8 to 10% of the world's population has blue eyes, concentrated heavily in Northern and Eastern Europe, with lighter distribution across other regions through migration and mixing populations. Brown eyes remain overwhelmingly dominant globally, present in somewhere around 70 to 80% of humans on Earth. Every blue-eyed person you have ever met is, statistically, carrying a rare mutation, a genetic minority trait, hiding in plain sight inside one of the most looked-at parts of the human body. There's something worth sitting with here. Your eye color was never a choice, never a personality trait, never a sign of anything beneath the surface. And yet you have almost certainly formed an instinctive impression about someone based on it. Maybe you found a certain eye color striking without knowing why. Maybe you've heard someone described as having cold blue eyes or warm brown eyes, language that has nothing to do with actual temperature and everything to do with an ancient, half-buried instinct still firing in the back of your brain. Walk through a modern dating app for 30 seconds, and you'll see this instinct still running in the open. Profile after profile, people mentioning eye color unprompted, as if it were a personality feature rather than an accident of scattered light. Advertising, film, and magazine covers have leaned on the same fixation for generations, casting certain eye colors as mysterious, others as trustworthy, others as exotic, all of it built on nothing more than how much melanin happened to sit in one small ring of tissue. None of that meaning was ever really there. Humans built it, layer by layer, on top of a biological accident, the same way people once built entire constellations out of stars that have no actual relationship to one another except sharing the same patch of sky. Even now, cosmetic contact lenses exist purely to let people manufacture a rarer eye color than the one they were born with, an entire industry built around chasing a genetic accident that, 10,000 years ago, nobody asked for and nobody could have predicted. The mutation that once helped one small population survive a brutal winter has become, in the space of a few hundred generations, a global aesthetic ideal, stripped completely of the environment that created it. You are not imagining that reaction. You inherited it. It's the same instinct that may have helped a rare mutation spread across an entire continent thousands of years before anyone understood genetics, before anyone had a word for melanin, before anyone could explain why some eyes looked different from others. People were just responding, choosing, noticing. And somewhere in that ancient noticing, one person's genetic accident became the eye color of hundreds of millions of descendants scattered across the modern world. Think about how many things had to go right for that single mutation to still be sitting in your face, or your friend's face, or a stranger's face on the train this morning. It had to survive childbirth in a world with no medicine. It had to survive famine, war, migration, disease, and thousands of years of pure chance, generation after generation, without ever once breaking the chain. Most genetic mutations don't survive that long. Most vanish within a few generations quietly, without anyone ever noticing they existed at all. This one didn't. This one kept getting chosen, kept getting passed forward, kept surviving long enough to end up in you, or in someone you love, or in someone you can't stop looking at across a room. So the next time you make eye contact with someone, whether it lasts half a second on a train or holds a little longer than it should across a room, remember what's actually happening. You are not just seeing a color. You are seeing physics, scattering light exactly the way it scatters across the sky. You are seeing a mutation that started in a single human body thousands of years ago and somehow survived every famine, every migration, every war since. You are seeing the residue of an ancient, unconscious system for deciding who to trust and who to want. You looked in the mirror this morning and saw your eyes. Now you know they were never really about you at all.